Section 5.3 is all about solving trigonometric equations, and we're going to be using some of the identities that we learned in the last couple of units, or sorry, last couple of sections to help us solve these trig equations. And when we talk about trig equations and solving them, we're going to need to know that unit circle inside and out, because there's going to be a lot of times where we're going to say, okay, well, on the unit circle, when is cosine equal to this, or when is sine equal to that? And if you don't know that unit circle, that's really going to be difficult for you. So when we solve equations, like I was saying, we use our knowledge from unit circle. So for this one, sine x is equal to 1. We say, oh, the equation, the solution is pi over 2. But we know that since it's the circle goes on forever, that pi over 2 is not the only solution. 5 pi over 2 is another solution. 9 pi over 2 is another solution. And we could keep going. So what we're going to do to kind of just make this a little bit more manageable for us is that we're always going to have the restrictions that our answer is going to be between 0 and 2 pi, or 360 degrees. The book will sometimes go on forever, but for all of us, we're going to be doing 0 to 360 or 0 to 2 pi. I want to point out that just like how we should never divide by x, we should never divide by a trig function. For example, if we had this and we divided to this and then divided everything by x, you say, oh, x equals 1. And yes, that is a solution, but if we would have factored out a GCF instead, we now have two solutions, x equals 0 and x equals 1. So by dividing by x right here, we actually divided by 0, and that's not allowed, and we miss a solution. The same is true for trig functions. We're not going to divide both sides by a trig function. We're going to factor instead. So example 1, find all the exact solutions on the interval from 0 to 2 pi. Solve all algebra. We're going to show all algebra work. So cosecant x minus 2 equals 0. We're going to add 2 to both sides, so this becomes cosecant x equals 2. Now, me personally, I don't look at that and say, oh, I know on the unit circle cosecant of this angle equals 2. However, I know that cosecant is sine flipped, so I can change this to sine x equals 1 over 2. Oh, on the unit circle, I know that sine is 1/2 at positive pi over 6 and at 5 pi over 6. Those are two angles that have a sine value of 1/2. So it's like when we did those inverse problems back in chapter 4, but now we're actually solving equations. Now, letter B. Secant x times cosecant x equals 2 cosecant x. Again, we don't want to divide by cosecant x. Instead, we're going to get this equal to 0. So many of these problems, we want to treat them kind of like quadratics, where we want to set it equal to 0. That's not always going to be the case, but a lot of the times it is. So we're going to do this part. So then we have secant x times cosecant x minus 2 cosecant x is equal to 0. Now we can factor out a cosecant. You can factor out a cosecant. We're left with secant x minus 2 equals 0. So now we set each part equal to 0. Cosecant x is equal to 0, and secant x minus 2 is equal to 0. Well, again, cosecant is 1 over sine, so this means sine of x would equal 1 over 0. That's not possible. Sine is never undefined. Sine is not undefined anywhere, so no solutions for that part. Now over here we add 2 to both sides, so we get secant x equals 2, and then we're going to switch this secant to cosine. So cosine x equals 1/2. So again, on the unit circle, cosine is equal to 1/2 at positive pi over 3 and 5 pi over 3. And those would be your solutions. Now let's look at letter C. Letter C is interesting because we have, again, 2 trig functions with a subtraction sign, and when I subtract them, we have to equal 0. I want to think about this a little bit, because if I were to subtract 2 things and they equal 0, that means they must be exactly the same, like 5 minus 5 is equal to 0. So what this means is that for this equation, these two have to be exactly the same. Sine has to equal cosine. Or if we added cosine to both sides, okay, sine theta equals cosine theta. Well, on the unit circle, when does that happen? That happens in quadrant 1 at pi over 4, because square root of 2 and the square root of 2. It also happens in quadrant 3, where sine and cosine are both negative square root of 2 over 2. So this one, we had to do a little bit more thinking, but that's what we have to get good at, is thinking about what these problems are asking us and looking at it as a whole, not just a narrow set of rules to follow. All right, so now letter D. We have 2 cotangent x plus cosecant x equals 0. Again, we can't solve this right now because we don't have the same trig function and we can't factor anything out. So if we change this, we know that cotangent is cosine over sine. So 2 cosine x over sine x, and we can change cosecant to 1 over sine x. So now we have some similar trig functions, and what we can actually do is factor out a 1 over sine. And then that will leave us with 2 cosine x plus 1 equals 0. And again, if you ever are unsure about how you can factor a GCF, if I were to multiply this back in, I would get what I had in light blue. So this is something else that, we kind of did this with partial fraction decomposition, where we factored out a fraction. So this is an extension of that. So now I can set both of these equal to 0. So 1 over sine x is equal to 0. And 2 cosine of x plus 1 equals 0. Now, the first one, 1 over sine x equals 0, that can't happen because the only way for this fraction to equal 0 is if the numerator was 0. Well, it's a 1 there. There's no variable. There's nothing there. So this has no solution. Now, over here, if we subtract 1 from both sides, we get 2 cosine x equals negative 1. Divide both sides by 2, we get cosine x is equal to negative 1/2. So on the unit circle, cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So those would be our 2 solutions. Now, example E, we have 4 sine squared minus 3 equals 0. Now, you might be saying, oh, can we use a trig identity? Yes, you could use a trig identity, but that's just going to add more to our problem. So if we add 3 to both sides, because we want to try to get this sine squared by itself. All right, then we can divide both sides by 4. We get sine squared x equals 3 over 4. Now we have to square root both sides. And remember, when we take the square root, we must use plus or minus. So we get sine x is equal to plus or minus. The square root of 3 is just the square root of 3, but the square root of 4 is 2. So for these problems, you're most likely going to get answers that are on the unit circle unless otherwise specified. So if I would have gotten like square root of 5 over 4, like that would have told me, hey, maybe I did something wrong because that's not on the unit circle. Square root of 3 over 2 is. So sine is equal to the square root of 3 over 2 at pi over 3 and 2 pi over 3. But we also have to worry about the negative. So this sine is equal to negative square root of 3 over 2 at 4 pi over 3 and 5 pi over 3. So those would be our 4 answers. All right, now with letter F, it's 3 times tangent squared x minus 1. So we'll add 1 to both sides. We get 3 times tangent squared x equals 1. Then divide both sides by 3. So tangent squared x equals 1/3. And now when we square both sides, we get tangent x equals plus or minus 1 over the square root of 3, because the square root of 1 is just 1. Now we can't have that square root of 3 in the denominator. So then tangent x equals, if we multiply the top and bottom by the square root of 3 over 3, we get tangent x equals plus or minus the square root of 3 over 3, which we know that tangent is equal to this at multiples of pi over 6 because 3 plus 3 is 6. And we want the positive and negative, plus or minus. So we got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So at all of those solutions, all of those angles on the unit circle, tangent is either positive or negative square root of 3 over 3. All right, now the last thing we're going to do is we're going to verify that this is a solution. So we're not solving, we're verifying. So we're going to substitute this in for x. So 4 times cosine squared of 2 times pi over 8 minus 2 equals 0. Okay, so we get 4 times cosine squared of 2 times pi over 8. That's going to be 2 pi over 8, or pi over 4. So the cosine of pi over 4 is square root of 2 over 2, but it's cosine squared. So 4 times the square root of 2 over 2 squared minus 2 equals 0. Because we evaluated the cosine of pi over 4 and got square root of 2 over 2, but then we had to square it. All right, so then this becomes 4 times 2 over 4 minus 2 equals 0, because you square the top and bottom. These 4's are going to cancel, so we're left with 2 minus 2 equals 0, which I think we can agree 2 minus 2 is equal to 0. So again, solving these trig equations, you do need to know your unit circle. If it helps to have one out with you while you're first learning this, that's fine, but just know that if you spend most of your time trying to figure out the unit circle, you will most likely run out of time on any test or quiz because you have to know that. So that's it for the introduction of solving trig equations. Tomorrow we're going to go a little bit more in depth and do some more difficult ones. So thanks for watching. Make sure to like the video and subscribe.